Factors affecting discharge of ions. Factors affecting discharge of ions during electrolysis. One of the factors that affect discharge of ion is position of the ion in the electrochemical series. Position of the ion in the ECS. Position of the ion in the ECS. That ECS for short, for electrochemical what? Series. Then the second is concentration of the ion in the electrolytes. And then next one is what? Nature of what? Electrode. Okay. All right, let's look at this. Now we have an electrochemical series for cations. That is, those negatively charged ions for cations, which of course you know that metals are electropositive. And all electropositive chemical substances are what? Metals. Are there? So we have the hierarchy or position of these metals. There are criteria that are considered in placing these metals in these positions. I mean, one of the criteria is reaction of this metal with water. With water. It was discovered that metal that reacts vigorously with water to displace hydrogen is potassium. Okay? Is what? Potassium. Then followed by sodium. So these two metals are represented here. That's the criteria I'm using now to arrange this metal now. First is what? Potassium, followed by sodium, and then we can have what? Calcium, that's of group 2, and they have what? Magnesium. What this analysis means that reference to your periodic table, going down the group, these two elements are elements found in group 1. Going down the group, what happened to reactivity of metal? Is it increasing or decreasing? Is it increasing or decreasing? Is what? Going down the group, reactivity of metal increases, of course. Reactivity, which metal in group 1 is more reactive? Which metal? Going down, the most reactive metal of group 1 is what? Cesium or franc. If you want to reach there, the last one, you can say francium. The least there is lithium. Are you know, the most reactive? So if you look at sodium, look at potassium, which one is placed before the other? Sodium is placed before what? Sodium is placed before potassium. But potassium is above now because it is more reactive than what? Sodium. Are you with me now? If you come to this group 2, we have magnesium and calcium. Which one comes before the other? Magnesium. But here, calcium is now placed above magnesium because going down the group, reactivity or electropositivity does what? Increases. Are you with me? Not decreases at all. You can't say that sodium is more reactive. You can't say that sodium is more reactive than potassium. No. React both with water and see which one will be more reactive. In fact, potassium reacts with water violently. Sodium reacts with water readily. So that shows that potassium is more reactive than what? Sodium. So if we go down, we go to group 3, we have only one member that represented there. Aluminium. Then we have carbon. Are you with me now? And then after carbon, we have what? Zinc. We have zinc there. After zinc, we have what? Zinc, we have lead. We have tin. What else? Am I correct? I missed iron somewhere here, Abby. I think iron here, Abby. Then tin. Then what? Lead. Then what? Hydrogen. Then copper. Then mercury. Then what? Silver. And then we have what? Gold. Going from here to here, what happened to the reactivity? Decreases. The least reactive of them is gold. The more reactive is what? Potassium. Are you with me now? But contrary to what we have here, in terms of which ion, suppose you have competing ion. Suppose we have competing ion. You know what I mean, competing ion? We have two ions that are to discharge to one particular electrode. We have two similar ions. Okay. Supposing I have something like copper 2 tetra oxosulfate 6, okay, which in its solution splits into copper 2 and sulfates ion. Okay. I'm also going to write ions that are present in water, which is what? H plus and what? OH what? Minus. So it's now see that there are how many ions present in this electrolysis? 4 ions. Are you with me now? That means 2 will go to a particular electrode. 2 will go to a particular electrode. Which one goes to the cathode? This goes to the cathode. That means to what? Cathode. And this go to what? To what? Anode. But when these 2 are going to the cathode, 2 of them cannot go at the same time. One is preferentially selected for discharge. So which one is selected for discharge? This is one of the factors now, which is position of the ion. So which one goes in preference to the other? Which goes to the preference to the other? Now, to know which goes to the preference to the other, the rule is simple. The lower the cation or the ion, the ease of discharge. Then check the 2 ions. Which of these 2 ions appears to be lower in the series? Come to the series and check the position of copper and hydrogen. It appears that copper is below hydrogen, or that hydrogen is above copper. So it means that hydrogen is higher than copper, or that copper is lower than what? Hydrogen. So which one is lower now? Copper. So copper here is preferentially what? Discharged. Are you with me? Copper is discharged preferentially. And then hydrogen remains back in the electrolytes. Copper is discharged. So the reason for copper being discharged is because of what? Position. So the lower the ion, the ease of what? Discharge. Then basically for cations migration, like the reason why copper is migrating and not hydrogen is because copper, we have the more tendency, we have that tendency to be discharged, because most things that happens at the cathode whenever ions goes, that an ion will go to the cathode, and going there, basically the ion will get reduced. And this is to say that at cathode, reduction takes place at what? Cathode. And what is reduction? Based on our definition, we say that reduction is the gain of what? Electron, isn't it? So when copper goes to the cathode, it migrates there to gain or lose electron, because it's going to reduce to what? Gain electron. Are you now? So in that regard, copper migrates, but on reaching to that particular electrode, that which is cathode, it gains how many electrons to reduce? 2 electrons, and then now got what? Reduce. That means copper is no longer in the solution after losing electron. Now it gets itself deposited at the cathode. Now the state of matter of copper will now change to what? Solid. And then what happened to the electrode after the deposition of copper? Is the electrode going to increase or decrease? Supposing I have this electrolytic cell, I have this to be cathode. Sorry, anode, plus I have this to be what? Cathode, isn't it? I have this to be my electrolyte. The electrolyte is CuSO4. And then at the cathode, copper comes from the solution. It's not going to be here again. It's going to migrate, left the solution, this is the solution, and then what remains in the solution will be what? Hydrogen ion. So copper goes in here, but as it's being discharged here, it's going to, because this particular electrode, or what do you call it? The copper is not going to go to where it's positive. Remember? Because its charges are like charge. So let's say all these cations goes here, not there, H plus. So I'm going to have the other ones here, okay, which is to be written later. So this is going to get deposited here, because look at the charge mass. So this is going to be attracted here. So I'm going here. This particular electrode cathode is efficient with the electron. So all the electrons here will what? Will be gained by this copper. Okay. And as it gains, then copper now get itself deposited and then increase the mass of the electrode. Can you see how the mass increase? Because copper is discharged there. The mass of the cathode increases. Are you there? So I'm getting here now. The question will be copper 2, which was in aqueous state, gains 2 electrons from the cathode and then get itself deposited on the same cathode and then got reduced to copper. So the matter state will change from aqueous to what? Solid. In this reaction, the oxidation state of copper has just changed from +2, are you with me, to what? 0. So in this particular electrode, what happened to this particular electrode is what? Reduction. So reduction takes place at the cathode. Are you with me? That is on that aspect. Then on the second aspect, when we have these two of these cannot go, just like this. One remains in the electrolyte. So which one goes to the cathode? Just like we have this position for cation, we also have position for anion. That position for anion, F minus, SO4, 2 minus. We also have NO3 minus, Cl minus, Br minus, and what? OH what? Minus. The lower the cation, the lower anion here is what? OH minus. So look at SO4 here. So which one is discharged in preference? OH minus. So OH minus leave the solution and go somewhere here. Okay. Now this particular electrode is electron deficient. That's the anode. It's not as electron efficient as cathode. This is deficient. This is efficient. That's why here electrons are gained, but here electrons are lost by the ion. So it means that this OH minus we give this anode electron. That is to say that in this case there will be clear case of oxidation, because oxidation here is the word gain. Sorry, is the word loss. It has lost electron to the electrode. And now that it has lost electron, what happened to the OH minus? It decomposed to give you what? H2O. Are you there? And then checking is to balance the equation now, because it's decomposing, have to balance the equation since you have 2 here. And then you have what? O here, 2, O1. So you have to put another oxygen to balance it. But since uncombined oxygen does not exist, what you do is to have 2 here and then balance this one afterwards and then put 2 here. And then now check how many charged electrons do you have at the reactants? -4. So here is -4. So here should be -4. To reconcile the charge on both sides, what do you add to this side to balance it? 4E what? Minus. So you now check what oxygen is here. The reactant is -2, but over here is what? 0. So you mean that in this reaction, oxygen has what? Oxidized. So at cathode, oxidation takes place. So what happens at the cathode? It means that you're going to see bubbles all over here to show that gas is given what? Off. The gas given off at anode in the electrolysis of this salt is what? Oxygen what? Gas. And in this case, the electrode here must be inert. Inert in the sense that they must be made of either platinum or what? Carbon. I don't know, both of them must be made of what? Either platinum or what? Carbon. Because if they are not made of platinum or carbon, it means that the active or reactive electrode is going to interfere with the reaction. Now that these 2 electrodes are not active, they are not going to interfere. The gravitational factor that affects electrolysis is what? Is the nature of what? Electrode. So since the electrode appears to be inert, they have nothing to do with the discharge of what? Ions. Are you with me? Are you with me? Are you with me? Okay. That is for position of the ions. Now, there is something that is still remaining there. Those ions that did not migrate, that remains in the electrolyte. What happened to it? Like hydrogen did not go, and the anode, SO4, is also not discharged. So what happened? Both of these ions combines, okay, and then they form what? H2 what? SO what? 4. Are you seeing it? So it means that at the end of this reaction, or this electrolytic reaction, what is the nature of the electrolyte? What is the nature of the electrolyte? There are 3 things that happen here. The mass of the cathode increases. Effervescence happens at the what? Anode. Are you with me? And then the electrolyte here becomes what? Acidic.